Okay, hello guys. So here we are having one doubt that what is the minimum acceleration with which a monkey must climb the rope so that it does not break. Okay. So how does the problem follows as thus that suppose if we have got a rope, okay, suppose if we have got a rope out here and the maximum tension that the rope can sustain, yeah, the maximum tension that the rope that the rope can sustain can sustain is T. Okay, fine. And suppose if there is a monkey, let's say me myself, yeah, I'm hanging with the rope, right? And my weight is 65 kg, yeah, for the record. And the maximum tension that the rope which it can sustain, suppose it is your 100 kg mass. Okay, fine. So it means what? That if my mass is 65 kg, right, and it can sustain the mass of the 100, right? So it means that if I will be just hanging with the rope, if I will be just hanging with the rope will not break. Yeah, it's a fact. Why? Why so? Because you see that the T max, the T max tension there is a force, right? So I can write the 100 into 10 where the 10 where the g equal to 10 meter per second square. Okay, so it will be your force, that is your 1000 newton. Okay, fine. So it means what, that the rope can sustain the maximum weight or tension is the 1000 newton. Fine. And the force that I am exerting on the rope in the form of my weight is, my weight is 65 kg, right? So in that case, I can write it out 65 into 10, this is a mass, okay, into g, yeah. So it will be over 650 Newton, fine. So we see that my weight is 65, my weight is 650 Newton, and the tensile maximum that the rope can sustain is the 1000 Newton. So it means that if I will be just hanging with the rope will not break. I'm just hanging with the rope will not break at all. Okay. And now suppose if I will try to climb the rope, okay, fine. If I will try to climb the rope, if I will climb the rope, if I will climb the rope, then two things may take place. The first thing is that I may climb the rope with an acceleration. Yeah, I may climb the rope with one acceleration, and it may also happen that I may climb the rope with some velocity, constant velocity. I'm sorry for that, constant velocity. Okay, so we have to see that what actually happens to rope in both the things, in both the cases. Okay, fine. So we see that first of all, if I will be moving upward with a constant acceleration, and this is me myself, and this is the rope, and I am moving upward with a constant acceleration, say a, right? I have to find out that what is the minimum acceleration with which I should climb the rope so that the rope must not break. What is the force acting out here? Tension. Okay. What is the force acting in the downward direction? Mg means my weight itself, right? So if my body is moving in the upward direction, means what? That the force in the upward direction is more than the force in the downward direction, right? Means that if you wish, I can explain you with one example. See, suppose if one force is acting out here, say F1, and if one force is acting out here, say F2, right? And here it has got the mass M, and this body is moving in the direction of the force F1, right? This is the direction in which the body is moving, right? So we can conclude from here that F1 is more than F2, fine. And if F1 is more than F2 means what? F1 minus F2 will give you the net force, the net external force that will be acting on the body will make it to move with an acceleration A, and hence it will be equal to ma. Fine. right? So means what? The direction in which the body is moving, that force, the force in that direction is more than the force in the opposite direction, and the difference of these two forces will give you the net force acting on the body that will make the body to move with an acceleration a. Fine. Okay, so we will be applying the same formula out here, and we see that if in the upward direction your force is acting T, and in the downward direction it is your mg, so body is moving in the upward direction means T is more than mg, right? So the T minus mg, and the body is moving upward with some acceleration, that is your ma. Fine. Fine. Okay, perfect. Suppose if mg will be more than T, right? Then if I will be just hanging with the rope will break. Yeah. If my weight is more than the sustainable tension of the rope, right? Then it will break if I will be just hanging with the rope itself. Okay. But suppose if I am moving with some acceleration which is more, right? Right? So in that case, the T will be equal to mg plus ma, right? Right? Say suppose this is the T1, okay? So this will be your mg plus a, fine? T1 is there, right? And if the value of this T1 is more than the maximum value of the tension that it can sustain, right? Then the rope will break. The rope will break, okay? And if suppose this T is 1 is less than T max, right? Then the rope will not break, will not break. So here what it is asking that what is the minimum acceleration with which you should move upward so that the rope will not break. Means the value of the T1 that you should calculate should be less than the value of the T max, and for that case the rope will not break at all, right? This was the first case. Now we will see for the second case where you are going upward with a constant velocity. Yeah, going upward, going upward with a constant velocity. Okay. So if I write that if I'm going upward with a constant velocity means no change in the velocity with the time, right? Velocity with time, right? And we know that dv by dt equal to a, right? So if your dv by dt is 0, then the acceleration will become 0. Okay, fine. In that case, I can say that yes. In that case, I can say that if I am moving upward with the slope along the rope, right, with a constant velocity v, then acceleration is 0, right? Then in that case, the t that I will exert on the rope will be equal to the weight myself, t minus mg. Why so? Because as you have seen in the earlier expression that t is equal to mg plus ma, okay, and where a has become 0, so in that case I can say that the t will be equal to mg itself, okay, right? So if I am moving with a constant velocity, in that case the tension that will be induced in the rope will be just equal to the weight of myself or the monkey, whoever he be or she be, okay, fine. And if I am moving upward with an acceleration a, then the t it will be equal to mg plus ma, okay. And if this t value is more than the maximum tension value that it can sustain, that the rope can sustain, then the rope will break. And if it is less than that, then the rope will not break. Okay. So stay tuned for more doubts and its solution. Okay. Thank you very much for watching my video.